Hey people! So this is a short video that I wanted to make about bindless rendering and texture collections. It's in Unreal Engine 5.6 and 7. This is a new feature that Unreal added in 5.6. It's tagged as experimental, so be wary of it because it tends to crash, but nevertheless it opens up a lot of doors for optimization and different workflows. Basically what it does is you don't have to assign a texture to a texture sampler manually each time and have it bound to that sampler, but rather you have a texture collection with a lot of unique textures on it, and then you get that texture from it by passing the index inside of the material. In practice, that allows you to use some parameters such as custom primitive data to swap the textures on the asset instead of doing separate material instances. To get bindless working in 5.7, you have to input a couple of parameters in your default engine.config file. This section here, which I couldn't get this to work. I couldn't get bindless to work in 5.7 without it. It was crashing the material compiler. In 5.6, I didn't have to input that, so that's something new. And also these parameters here. I believe these are 5.6 exclusive, and this is for 5.7. Anyway, once you've done that, you can start the project, and here I created a debug grid of many cubes, many meaning 4096, which means in this case that I am creating 4096 unique static meshes, unique cubes here, static mesh components. They are not instanced, it's just for demonstration purposes. So by default, each of those cubes has one material slot and has a unique material assigned to it. I know that they look the same, but I only have 5 textures over here, but trust me, each of those cubes has a different unique material instance on them. So very quickly, very roughly looking, we can see that rendering time on GPU for it takes 1.2 milliseconds, which is when all of the materials use material instance dynamics. I also have a switch here for using material instance constants, which are in the folder over here, 4096 unique material instances, just to simulate how you would have a lot of materials inside of your project and multiple meshes using different material instances. The result when clicking that should be relatively similar to what you do with material instance dynamic, because in the end it's just a unique material instance on each of those cubes. Now I don't have to change anything here, but let me enable bindless, and you can see that my rendering time went to about 0.9 and sometimes jumping even down to 0.8. So it's a decrease of about 20% in rendering time, 25% in rendering time of this scene, which is, I would say, quite significant. You can also, if you want more precise timings, we can do it right now even. We have to enable show material draw events and run insights. Let me open insights after trace. Let it run for a moment. Cool. Let me select a random frame. And somewhere over here, I should have that in base pass, right? Yeah. So in base pass, I have now a single material. Those are from another debug object that I have in the scene that I haven't showed yet, but in general I have a single material taking all of the shading process inside of Nanite base pass. Now for comparison, let's see what happens if I disable bindless and run the profiler again. Okay, you can see that I have an absolute ton of different instances here. Each of those is a separate call to draw that asset. It's not a draw call, but a separate piece has to be sent, a separate command has to be sent over to the renderer to get that working. So what we try to do here with Bindless is basically get rid of each of those separate calls and each of those gaps and just batch it in one place, as you saw before. So let me walk you through what's actually happening here, and let me go back to Bindless because it's faster. And I can now also disable the material throw events. So walking you through what's happening here. After I enabled Bindless in the config, I created a data asset, which is commented out for your leisure here. It's very simple data asset, which I called BindlessDataConfig, and it contains a single array of FG Bindless mesh descriptors, which is an array that contains a static mesh, whatever static mesh that you want, and some index assignments that go over for each material slot and then are passed over to your custom primitive data. You can pass over other arbitrary data through it, such as, I don't know, color, other textures, whatever you want. But that data has to be sent over through custom primitive data values. So after I created that, I created this Bindless data config, and I input my Bindless cube, which is the one that you see over here. Its indexes don't really matter over here because I am overriding that anyway. And I also have another cube with 4 materials that I will showcase later. Let me go over to the actual spawner here and what it does. So that's it. I'm running it all on construction script because it doesn't really matter for this tutorial, but what happens here is I get the asset path first with all of my material instance constants. That's for demonstration purposes for the material instance constant section. And then run a loop with my number of cubes, so 64 by 64 here. And I spawn a static mesh component for each of those iterations with some offset to have that grid. And then I have my switches for Bindless and material instance constants that I showcased earlier. Material instance constants gets it from this asset registry in the beginning here. So I get all of those. I get my current cube index that you could see earlier as well. I get the asset, I load it, I cast it to constant and assign it. And also similar thing happens here. Instead, I just am creating a material instance dynamic and sending it to the material and also setting the texture over here. Nothing really fancy. This section over here is really just for demonstration purposes. But with Bindless, I am setting a single material on this cube, on all of these cubes really. My material slot 0 Bindless, which is an instance of my master material for Bindless. Then I get my mesh descriptors, which are basically this data asset. My mesh descriptors from inside of Bindless data, which this Bindless data is the data asset that I showcased over here. I get my mesh descriptors from it, so all of the entries in the array. And I check each of those entries if my static mesh that I just created in the blueprint is the same as exists inside of my Bindless mesh descriptors. And if that's true, I am setting some variables over here. Normally, I would pass some data to it from my mesh descriptor, from the index that I want to bind to. But right now, I am just doing a random lookup. And what this lookup does is it sends an ID. It sends an index over to my custom primitive data that looks up the texture from a texture collection. So a texture collection is a new asset that you can create by searching miscellaneous data asset and inputting texture collection over here. And it's this data asset which contains a series of textures that I input over here. Each of those textures is at a separate index, and this index is what I am assigning over here. So this is telling me to, so this is assigning the index on the custom primitive data float. And this custom primitive data float is read in my bindless material, and it's read over here on my material index 0 slot, which is on custom primitive data index 0. And as you can see, I am sending custom primitive data index 0 over here. Let's quickly walk through this material because it is slightly different from what was shown on the Unreal Engine product board, which was this. What I have here is a regular switch node, and I am switching the custom primitive data that I want to use for this material by inputting a different material slot. Now this is relevant if I have a object that has multiple material slots, and as you can see, each of those slots uses the same material with slot 0, slot 1, slot 2, slot 3 in the relevant slot. All of the other objects that I would have in the scene would ideally also use the exact same configuration per slot, because I don't really care about it. I don't really care about having different materials. I really want to have the same material everywhere on each of those slots. And then once I get that index, it's read here. I have to cast it to uint, and then I am just getting a collection index, or I am looking up the texture from the texture collection by the index that I sent from the custom primitive data, and I am binding it to a texture. Important note that I have to set a sampler to something other than from texture asset, so I set it to wrap here. And that's really it. We can go through this asset. This is a texture, this is a cube that I showcased right here with 4 different material slots. And has a separate blueprint that spawns it right here. So it does the same thing that the grid blueprint does, but in a more simpler manner. Here I am doing the same thing really. I am getting my bindless data with mesh descriptors, and I am looking that static mesh that I spawned here, which is like only this cube. Looking it up, matching it, and if it is a match, I am sending the indices from this mesh descriptor over to the custom primitive data 0, 1, 2, and 3, which correspond to material slots. So each of the walls of this material has, of this cube has a different slot, or rather, not every one of those walls, but there are 4 material slots on the cube itself, like 1, 2, 3, and 4. Those are different material slots. And all of those have a different texture assigned to it, because here in this data asset, I am assigning texture for slot 0 to be 0, for 1 to be 1, 2 to be 2, and 3 to be 3. And this is looking up these textures, 0, 1, 2, and 3. So we can, for example, where is it? Change this assignment to be 4. And now instead of looking up texture 0, which was the imperfections, it will look at texture at index 4, which is the purlin mask. And of course, I have to recompile the blueprint to have that assigned. and now it goes for the texture at index 4. And that's really it. It's just assigning this custom primitive data, which is used to look up the index in this texture collection, and it's looking this index up from this material. Yeah, that's it. The benefits of that is that it allows you to pretty much, if you really want it, to have everything running on custom primitive data. So all of your textures can be on custom primitive data, all of your colors, all of your some other variables for shading, and really speaking, you can probably have the entire project running on only a few material instances. Now, there are quite severe limitations for this technique right now, but I really hope that Epic continues to make it better. For example, now it is crashing a lot on applying materials, and it's crashing a lot on adding new textures over here. It's also not ideal workflow because I cannot really see what my object looks like in the static mesh browser. I can only see what it looks like in the world after I have assigned the correct material primitive data defaults, custom primitive data defaults. Another issue with that is that I should have, if I want to have different shading methods, I have to create different materials, different material instances. So if I wanted this to be, say, masked, I have to do it as well here, and change some overrides to sided shading model, like blend mode. All of those have to be assigned over here, so there are more permutations of this. This is also an issue in regular material workflow, so not that big of a deal. But a bigger deal is if you have some static switches over here in your parameters, then you also have to do more permutations. So you cannot really have like a super uber shader with all of the cases and only one material instance for the entire world, but you will have to create different permutations for your possible static switches here and different shading, blend modes and two-sided and whatever. Yeah, so some severe issues with that, some drawbacks for sure, but a very promising technique which allows you to squeeze some more performance from your games. Yeah, so give it a look. Let me know if you have done something similar or if you found this video useful. And yeah, that's it. Hope you enjoyed it. See you later.